Okay, so this is a video about two different ways to be able to define probability. One is what is called an experimental definition of probability. The other is what is the classical definition of probability. These are not the same. They are related, but they are not the same. So in the experimental probability, you're going to do something over and over again. You might flip a coin or roll a die or whatever. You're going to do some event over and over again. Okay, so the probability of some outcome from that event occurring is the number of times that event occurs over the number of trials. Okay, so let's say you flip a coin 64 times and 31 times it comes up as heads. Then the experimental probability of coming up with heads is 31 over 64. Okay, so classical probability is a little bit different. Classical probability doesn't actually do the experiment. It just says, like, the number of simple events that could happen, that are possible. Okay, so like in a coin toss, this number is 2, right? Heads, tails. In rolling a 6-sided die, this number is 6. It can come up as a 1, a 2, a 3, a 4, a 5, a 6. So this is the number of simple events that are possible, that could happen. Okay. Now, this is the number of ways A can occur. Okay, so like if we're doing the coin toss again, there are 2 possible outcomes, one of which is a head, right? So the probability of getting heads in a coin toss would be 1/2. Like if I wanted to know on a 6-sided die, the probability of getting a 1 or a 2, well, there's 6 different ways that die could land. There are 2 ways that you could get a 1 or a 2. You could either get a 1 or you could get a 2. So that means it's 2/6 is the simple probability. Now note, here my coin toss came up as a 1/2. Here, because I'm taking this as an experimental, I could get 31 out of 64, which is not a 1/2. 32 out of 64 would be a 1/2. These numbers are related, but they're not the same. So when do they start becoming similar, and how are they related? Okay, so we get this thing called the law of large numbers. Okay, this basically says as you do more trials of a procedure, right? So if you keep doing something over and over and over again, then the experimental probability of an event is going to get closer to the classical probability of the event. So if these 2 probabilities are being calculated correctly and you do more and more trials, then this number should be getting closer to this one. So in our example, like I could have gotten 31 out of 64 heads, which is pretty close to 1/2, right? Ultimately, if I keep flipping that coin, it's a fair coin and I'm recording things accurately, this number should be getting closer and closer and closer and closer to 1/2 every time I do a trial. Okay, so this is my law of large numbers. Not every time I do a trial, but it's going to tend toward that classical probability. Okay, now if these 2 numbers don't agree, the one you should actually trust is the experimental probability because it's the one that's actually happening. This is the theoretical one that is following the mathematics. But if you're having to doubt one of them, you doubt the theoretical one because it's possible that you are computing something wrong. It is not possible that what is happening isn't happening. Okay, so the experimental one gets pride in place over the classical probability. It's just easier to compute the classical one because you don't actually have to do a whole bunch of trials.